Hello friends, this video on Matrices part 33 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 32. Here that you have watched part 1 to part 34. Now we'll learn some elementary transformation of a matrix. So there are four kinds of transformation for a matrix. The first is interchange any two rows or column, multiplication of any row or column by a non-zero, addition to an element of any row or column, the corresponding element of another row multiplied by a non-zero number. Actually there are three. So first, before going through operations, what are operations? I'll give an example. For example, you have equation 3x is equal to 5y. Correct? So when I say addition operation is possible on this, when I say plus 2 on this, plus 2 is also here. Equation is still true. So this is one operation on this equation. So on equation, I can add a number on both sides. I can subtract a number on both sides. This is true, but I can't say into 0. I can't say into 0 both sides. This is not a correct operation. If I say into 0 both sides, both becomes null. Doesn't make sense. But when I say 3x plus 5 is equal to, let's suppose, 2y plus 3z, this is one equation. In this, I can add some number in both sides. I can subtract some number on both sides. I can divide also by 2 both sides. I can multiply this number also, same number. So I can say that in this case, division, multiplication, any number except 0, division, any number except 0, and subtraction and addition of any number. So these operations are true for such kind of equation. Similarly, for matrices, I have matrix A, let's suppose some matrix. Sorry, suppose this is my matrix. This is my matrix, some variable. Now, when I say interchange of two rows or two columns, that means if I interchange two rows here, I can interchange this two rows also here, and then still the equation will be valid. If I interchange these two columns here, I have to interchange these two columns also. Still the equation will be valid. Correct. Similarly, if I multiply these two, let's suppose by 3, this becomes 3 into 1, this becomes 2 into 3. I can multiply these also by 3. Still this equation will be true. Similarly, addition of element of this element with the corresponding element by adding one number. I'll explain this in the next slide. I mean, in fact, I'll explain all these, but what I'm trying to say is, why do we need elementary operation? The first thing is, we sometimes need to find inverse. To find inverse, we need elementary operation. It is easier to find inverse using elementary operation. Plus, in the field of science, technologies, when you want to reach to a particular matrix, then we can get that matrix by elementary operation. Because let's suppose we have these two matrices and we want to make this matrix as 0, 0, 0, 0, 0, 0. Then we can perform some operation on this. If you perform operation on this and you want to make this matrix equal, you want to perform the same operation on this guy also. Thus the matrix will be equal. Correct. So when I'm saying operation, I am not only performing operation on this guy. I have to perform the similar operation on the right hand side matrix also. Similar to this. In this case, when I'm saying plus 2, I have to add plus 2 both sides. When I'm saying minus 5, I have to subtract minus 5 both sides. When I say divide by 2 both sides. Multiply by 5 both sides. Similarly here also, when I say interchange rows both sides, interchange column both sides, or multiply particular row by a number, then you have to multiply a particular row by the same number in the right hand side also. We'll discuss more. Just understand what is operation and why do we need operation. We'll discuss the first operation. We'll interchange any two rows or column. So the example is, if A is this, I get this. For example, I'll tell you, if let's suppose I tell 1, 2, 1, minus 1, 2, 3, 1, 5, 6, 7. Correct. This is nothing but equal to some set A, B, C, D, E, F, GHI. Let's suppose. Now, when I'm saying I am applying a relation R1 is equal to R1 and R2, I am swapping, interchanging. See, when I'm saying like this, R1, R2, that means I'm swapping R1 with R2. When I'm saying R1, R3 like this, that means I'm swapping R1 with R3. When I'm saying C1, C2, that means I'm swapping C1 with C2. C1, C3, swapping C1 with C3. C2, C3, swapping C2 with C3. Please note, row will be swapped with row, column will be swapped with column. So in this case, let's suppose I am swapping row 1 and row 2, that is, this is row 1 and row 2. So this becomes, if you see, you swap this guy will be top, this guy will be top, this guy will become 1, root 3 minus 1. Similarly here also, since we swap this guy will go top. So this becomes DEF. These guys will come down, will take the position of R1, sorry, R2. So this guys will also come down, will take the position of R2, and this is 5, 6, 7, and this is GHI. So if you see here, if this equation is true, this equation is also true. Got it? Why we need operations? So if we have left hand side is equal to right hand side equality kind of matrix, if you're performing operation on this, you have to perform operation on this. Sometimes it is good because if you have a number and you want to, let's suppose, make it 0, 0, this guy, this place you want to make it 0, I can say this guy is equal to this plus this. So this becomes 0. So in that case, it's helpful. We'll solve some more examples to understand actually why do we need this operations, but just understand this is not saying only for one side. It's always left hand side and right hand side, and then only perform operations. Correct? If you're doing whatever you're doing here, if you're swapping rows, you have to swap rows here also. If you're swapping column here, you have to swap column here too. Let's take the operation 2. The multiplication of an elements of any row or column by non-zero. That means, let's suppose you have this matrix, you multiply column C3 by 1 by 7. Then you get this. So here also you see it is like this. You have this matrix 1, 2, 1, minus 1, 2, 3, 1. And then this is, let's suppose, equal to A, B, C, D, E, F. Now, when I'm saying C3 is equal to column 3, this is my column 3, is equal to 1 by 7 into C3. So what I'm doing, I'm multiplying all this number by 1 by 7. So what I'll get here is 1 minus 1 will be same only, 2 root 3 will be same, this becomes 1 by 7, this becomes 1 by 7. Correspondingly, this side also A, D, B, C remains same, but this becomes C by 7, this becomes F by 7. So this is one operation. Correct? This is one operation on this side, where you multiply one row or one column. For example, in this case also, this is called C3 is equal to 1 by 7 C3. If I want to multiply, let's suppose, now after this whatever I've got, I want to make row 1 is equal to 5 row 1. That means I want to multiply all the elements in row 1 with 5. With that I have to multiply all this element with 5. So I get 5 into 1, 5, 5 into 10, 5 by 7. This will be same because I'm not touching anything in this. Corresponding this one, you have to multiply by 5, this becomes 5a. This becomes 5b. This becomes 5c by 7. This is d, c and f by 7. No changing this. So if you see what we have done, we have changed this. So here we have applied R1 is equal to 5. So we can do anything for any row and column. We can pick any row or column in one step, and we can multiply or divide. Generally we multiply even divide also. See, multiplying with 1 by 7 is nothing but dividing by 7. So you can multiply or divide with a particular number. Non-zero number. Number has to be non-zero. So that kind of operation is also valid. We'll use these operations. I will give you one example where we'll use these operations. We'll take operation 3. This is a little complex operation. Please pay attention. Here you say we add the element of any row or column to the corresponding row or element. So if you take row, you have to use with row only. If you take column, you have to use column only in this. So you can take a row and add that to another row by multiplying with some number. You take a column, you add that with another column by multiplying with a number, non-zero number. Example, I'll tell you. You say R2 is equal to R2 minus 2R1. So if you say, let's suppose R1 is equal to R1 plus 3R2. Possible. You take R1, on that R1 you are adding 3 times R2. You take C2, you say C2 is equal to 5 times C1. That is also true. So what you are doing, you are taking a row or column, you are adding that with another row or column by multiplying the another row or column with some non-zero number. You can say C3 is nothing but C1 minus 1 by 6 C2. That is also possible, because here you are adding or subtracting, you are saying, correct, with another, sorry, this becomes C3. C3 only you are subtracting with 1 by 6 C2. Such kind of operation is also possible. So example I'll tell you. For example, in this case, or you have, let's suppose 5, 6, 2, 8. This is the number, and this is equal to A, B, C, D. Now, if I say R2 is equal to R1 plus R2. So what will happen? Row 1 will remain unchanged, but row 2 will become R1 plus R2. So this guy will become 2 plus 5, 7. This guy will become 8 plus 6, 14. Correspondingly, this guy A and B will remain unchanged. C will become C plus A, and D will become D plus B. Correct. Such kind of thing we'll use. I'll tell you one example. For example, we have to find the inverse. So where we say, let's suppose we have to find the inverse of this 5, 4, 3, 2. So I say this is nothing but this into some number A will be equal to 1, 1, 0, 1. Correct? That means A is the inverse. So now what we do, we keep multiplying and dividing this number with some number. And then we try to make this as 101, and into this will become A inverse. See, I'll show you. So this is, let's suppose, A inverse to be more clear. Don't write it. This is A inverse. This into A inverse equal to this. These numbers, somehow I can make it 1001. Correct? So this becomes some number, because I have got this, converted this to this form by using all the operations. Maybe I can say this is equal to this by 5, so this becomes 1. Then I subtract, I make somehow using operation, I make it this form. So this into A inverse, and then this will change. This will have some values. So whatever value you get here, I'll just put ABCD here, I don't know the value. That is nothing but A inverse of this. So finding A inverse is simple. You write this equation, apply all the operations, and make this 1001. So in that case, this becomes A inverse. So this is one example of operation usage. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.